Okay, so question 7. So 12 different video games showing substance abuse were obtained. The duration of time in seconds has a mean of 223 seconds, so it has a mean to that, with a sample standard deviation of 23 seconds. Construct a 95% confidence interval to estimate mu, the mean duration of time the video games to show substance abuse. Okay, now your flag should be popping up, right? Mean, so not proportion, but mean. So we're doing the same thing we've done so far. So again, hopefully you can relate which ones you're doing proportion and which ones you're doing mean just based off what you read from the question, right? So always read slowly, don't skim, because you know, when it comes to stats, you want to read slowly and understand every single word based off that. So again, we're doing mean, so we find S and our T value. S in this case is 23. N is 12, right? 12 video games. So therefore, we got to find a couple things. So alpha is 0.05. Degrees of freedom, in this case, is going to be 11. So if we go to our chart, alpha being 0.05, degrees of freedom 11, our t value is 1.796. Okay, so we go back. So we have those portions there. So therefore, our margin of error is 1.796 times 23 divided by the square root of 12. Okay, so doing that all, plugging in the equation, in the calculators, we should get approximately 14.614. Okay, so that's step one. So now we go to step two to get a confidence interval, right? So our mean was given to us to be 223. So 223 plus this number and then minus that number, right? So 232 minus 14.614 gives us about 217.386. And if we add it instead, we get 246.614. And there's your confidence interval. Okay. Now, believe it or not, a little background information about this question itself. You may have not remembered, but it's relevant to me, I guess, because I like video games. Is about 10, 15 years ago, even a little longer than that sometimes, is, well, a lot of parents were blaming their video games on their child's behaviors and stuff like that, violence against things like that, because the video games they were watching or playing were just violent, so they were mimicking that kind of stuff. So you guys don't know, this one pretty high when it comes to the government officials and stuff like that. And believe it or not, this scenario was kind of given to the courts itself. So what they did is they brought this data saying how violent things are, and the substance abuse. And the problem is, well, they picked the most brutal video games ever made. So obviously they're going to have violence and substance abuse on it. So these numbers were in the hours, right, when it came to it. The problem with that is it's actually something called biased, meaning you force the data to actually do that way, meaning it wasn't a complete, like a random sample. I didn't pick, 300 random video games and just did it. I chose the most hardcore. So your data was actually skewed and biased based off that. So because of what the courts found that out to be true, is they just threw the court case completely, because it's wrong. You cannot do that. It's in bias. So data and an experiment must be unbiased. And because it was unbiased, they threw it out. They had no case. And then as of now, right, the people have been trying to do studies, and they can never correlate someone playing video games and going crazy when it comes to it. Believe it or not, for me, since I worked a lot of times at retailing, it was kind of like stress reliever. So to me, when it came to that portion, this question is pretty interesting for itself, right? Because you know you can blame people that want to blame their parenting; they always want to blame something else, right? Is my philosophy. But a little background information, you guys are wondering that kind of question here. Okay, so, all right, let's do one more, and it's called the Atkins. I don't know if you guys have tried Atkins before, but it's an interesting program as well. So in a test for Atkins weight loss program, 40 individuals were selected for a trial. After 12 months, the mean weight loss was 2.1 pounds with a sample standard deviation of 4.8 pounds. If the weight loss is normally distributed, construct a 99% confidence interval to estimate the population mean weight loss. Can Atkins come out with a commercial saying their weight loss is on average 3.2 supposed to be pounds for 12 months? So it's population mean, right? So it's just like all the other ones have done so far. So first thing is going to find a couple things, right? Margin of error. So standard deviation in this case, they gave it to us to be 4.8. Sample is, well, how many people were tested? 40 individuals. And our t-value, so alpha in this case is 0.09 because it's 1 minus 0.99. And degrees of freedom is going to be 39. So if we go to our table, 0.01 is over here. Go down to 39 degrees of freedom. And there we go. So it's going to be 2.426. All right. So now we have everything we need. We can find our margin of error. So plug it in the calculator and slowly simplifying should give you 2.055 as a margin error approximately. Okay. So therefore now, according to our case, right, our mean was mean weight loss of 2.1 pounds. So plus or minus that value. Gives us 0.045 and 4.155. So approximately, the entire population of Atkins, you either, an average weight loss of about 1 pound or a little less than 1 pound or 4 pounds, which is, pretty good, right, when it comes to it. Right? So last scenario, right, interpretation, we are 99% confident that the population proportion of population mean, so I'll say it again. We are 99% confident that the population mean weight loss using Atkins program is between that number and that number. Okay. Right, so that ends the actual confidence interval portion. So the last couple scenarios is, well, what if we want to go backwards? Meaning, if I knew this, or I want some numbers between it, how many people do I need to survey in order to make this true? In other words, how do we make sure it's 40 or higher to make my confidence interval actually be true? Okay, and that's what it means by going literally backwards. Okay, so the next step we're going to do is if we're given the confidence interval and want to find the sample size needed to keep that interval. So to find the sample size, we'll need to identify a couple situations. Again, either we talk about mean or proportion because that changes the aspect itself. Okay, now here's going to be our equations when it comes to it. So if we're doing a confidence interval for mean, so for population mean, we're always going to be using this equation. Now notice it's a z-score, not a t-value. Okay? Now the good news is that z-score is the same as these ones here. So this is the only time we're going to be using z-scores for mean when we're asked to find sample size. I cannot stress this enough. When you're finding sample size, here's our equation for mean, and it is a z-score, not a t-value. And that z-score is the exact same one we've done for proportion. Okay? So that's the equation for that, and just don't forget to square after that. Okay? So where E is the margin of error, S is standard deviation, and C is the z-score for the confidence interval. Now, however, if we're doing it for population proportion, okay, well, believe it or not, we have different scenarios here. So if P hat and Q hat are given, then we're going to be using this equation. If they're not given, it is almost the same equation, but instead of multiplying by P hat and Q hat, we multiply by 0.25 instead. Okay? So those are our equations going backwards. So the whole process is identifying again, are we doing proportion, population or proportion, and then from there identifying which scenario we're actually in. Okay. So let's and something very, very important when it comes to it. So in both proportion and mean, we are finding the sample size n. So we'll always round up to the next whole number. Okay. And I'll talk about that right now, what I mean by round up to next whole number. Okay, so let's look at number 2 here. So suppose that you wanted to estimate P, the true proportion of students in your school who have a tattoo. Okay, with a 95% confidence interval and a margin of error no more than 0.10. What is the minimum sample size needed? All right, so let's do this. So what is the minimal sample size, right? So we're looking for n. That is what we're looking for, okay? Well, are we doing proportion or mean? That's the question. Well, they told us right in the first sentence, right? P, the true proportion, meaning now we're going to be dealing with one of these two questions, right? Either this one or that one. These are the only two scenarios for proportion. Okay? All right, next scenario. Are we given the percentage of people who have tattoos? Hopefully you say no, right? Nowhere in the question did it tell me, oh, this percentage have tattoos. So that's what I mean by p hat is not given to us in this question. So p hat, not given. So therefore, we're going to be using this equation for this example. Okay? So notice we only need two things, our z-score and our margin of error. So our margin of error is actually given to us here. Margin of error of no more than 0.10. Our z-score corresponds to a 95% confidence interval, right? So go into the box, 95% corresponds to 1.96. So therefore, plug it into our equation. It's going to be n is equal to 0.25 times 1.96 divided by 0.10 squared. Okay. So let's see what we get. So 1.96 divided by 0.10, square that, right? Squaring that. And then finally times it by 0.25 gives us 96.04. Okay, now here's a question. Can I survey 0.04 of a person? Hopefully you say no, right? That's not possible. So this is what I mean by you always round up, never down. Because if you round down, you're assuming you're taking away that person or extra person you actually have to survey. So believe it or not, this actually is 97 people we have to survey. That's what I mean by you always round up, no matter what the decimal is. Again, can't stress it. You always round up, never down to 96. So no matter what decimal it is, always go up to the next whole number itself. Okay? So in this question, our n is going to be 97.